on this first one, what is this? Okay, this is a rectangular prism, and I told you to shade in one base. I'm going to go ahead and shade in both, so that right there and that right there would be the base. Okay, number 5, what is this? This is a triangular prism. Here would be one of the bases, here would be the other base. Okay, what's number 6? Rectangular prism. Here's one of the bases, here's the other one. Okay, this one is a rectangular prism. Here's one base, here's the other base. Triangular prism. Here's a base, here's a base. Triangular prism. Here's a base, here's a base. Okay, triangular prism. Here's a base, here's a base. What's this one? Okay, this is a pentagonal prism. Okay, so here's one of the bases, the other pentagon's the other base, and then this one is a hexagonal prism, so that right there would be the base. Okay, so the stuff we're doing today is going to be really the same stuff we did yesterday, although we are definitely going to add in a few little things to what you're doing today. Okay, so looking at the back side again here, so prism, for prisms, total surface area, what's the formula for that?
2 times h plus 2 times
Okay, you're right. There is the 2 times the area of the base, but the way we wrote that is P times H plus 2 times B. Okay, what's the formula for lateral surface area of a prism? It's just P times H. Okay, what's the difference in these two things? Okay, the total is everything. The lateral is everything without the bases. Okay, total is everything on the outside of the shape, the three-dimensional figure. Lateral surface is everything but without the bases. Okay, what does the capital P stand for? Okay, remember it's not just perimeter, it's perimeter of the base. Okay, so on this one, we would be looking for the perimeter of that shape right there. On this one, we'd be looking for the perimeter of this shape. On this one, we'd look for the perimeter here. And on this one, we'd be looking for the perimeter here. Okay, what does the capital B stand for? It stands for area of the base. So we'd be looking for the area there, we'd be looking for the area there, we'd be looking for the area there, we'd be looking for the area there. Okay, what does the H stand for? Okay, good. It means the height, which, more specifically means the distance between the bases. It's how far it is between the bases, because sometimes it may be laying on its side, like this first one right here. This is actually the height that's running horizontal. This is the height, this is the height, this is the height. Okay, so we talked about cylinders yesterday also. Total surface area of a cylinder. Two pi r squared. And then lateral surface area is just 2 pi r h. Okay, so on the front, I'm just going to rewrite these formulas real quick just so I don't have to keep turning over, but lateral is pH, total is pH plus 2b. And for a cylinder, lateral is 2 pi RH, total 2 pi RH plus 2 pi r squared. Okay, so on this first one, what is this? Triangular prism. What does the capital P stand for? Perimeter of the base. So we've got to find the perimeter of this base right here. Now the problem is there's one of those sides that I don't know. Pythagorean theorem, which this is actually a Pythagorean triple. But if you forget that, you can just do Pythagorean theorem, 3 squared plus 4 squared, take the square root. And what does that give you?
5.
Gives you 5. So the perimeter of the base is going to be 3 plus 4 plus 5. So it's what? It's 12. Okay, what does capital B stand for? Area of the base. So I'm looking for the area of that. How am I going to find the area? 4 times 3 divided by 2, which is 6. And then what is the height of the prism? It's 10. Remember, it's the distance between the bases. So this time the height's running horizontal. Okay. Now, LA stands for lateral area, lateral surface area. So just P times H. So P times H is what? 120 square meters. Lateral is PH plus 2B. And that's what? 132. Or, no, what is it? Yeah, 144. Oh, 6. Okay, yeah, I knew. Okay, sorry. Something was not working there because, my bad. Area of the base is 6. Okay, yeah. So it is 132, sorry. Okay, on this cylinder, what's the radius? It's 4. What's the height? 12. Lateral surface area is 2 pi RH. What does that give you? 311.59? Oh, 301. Alrighty, and then for total is 2 pi RH plus 2 pi R squared. Which is pi RH, 2 pi RH plus 2 pi R squared, so 301.59, 402.12. Okay. Now, this next one. What's the perimeter of the base? Okay, it's 30. How are we going to find the area of the base? Okay, so to find the area of the base, we're going to have to do apothem times perimeter divided by 2, right? So, do I know the apothem in here? Nope. All right. So, that's the reason I put this here. And we are about to be going back to some math that we've done earlier this semester. So, I'm looking for the apothem here, from here to here. Now, what I'm going to do is I'm also drawing the radius from here to here. Okay, so there's a couple ways to get to this first part. We're going to do it like this. This angle right here is cut exactly in half with this radius that I've drawn. So I can know how big this angle is if I know this whole angle, because it's just half of it. Okay? So let's just go up here and think about this one. So the first thing I need to do is figure out how big this angle is right here. So how am I going to find out how big that one single angle is? Okay, the inside angles, and this would be another way to do it, the inside angles would be 360. But remember, there's a formula that I gave to you, and this has been quite a while ago. There's a formula to find the total of the inside angles here. Okay, and so the formula is n minus 2 times 180. So how many sides does this have? 5. So if I do 5 minus 2 times 180, what does that give you? It gives 540. But that's the total of degrees. I want to know how big one of these is. So I divide this by 5, and that tells me this is 108 degrees. Okay? So all of those angles would be 108. And same thing down here. This whole angle would be 108. This angle right here is half of that. So what's half of 108? Is 54. So this angle right here is 54 degrees. I'm looking for this side over here. How long would this side down here be? 3, because it's half of this 6. So this side is 3. So now what I'm going to do is I'm going to use, what do you think we're going to use here?
360.
Okay, that's definitely a good thought, but that's not what I'm going to use here. Okay, so I'm going to be using some trig here, okay? Plug this thing in. All right, so we're going to label this. From this angle right here, which side is the hypotenuse? The top one, this blank one. Which one is the adjacent? Is the 3. Remember, adjacent means the one right touching the angle. And then which one's, well, what's that other one? The what? The opposite, the O. Now, with those 3, H, A, and O, which one of those do I not need here? The H, that one's totally blank. It's the O and A that I care about. So, SOHCAHTOA. SOHCAHTOA. So which one am I going to be using here? Is the TOA, right? Because I have the O and A. This is the only one that has O and A. So the T tells me to use what? Tangent, okay? So this is how we're going to do it. The tangent of 54 degrees equals, now remember, this TOA not only tells me what function to use, but it tells me how to set it up. So we always put the opposite over the adjacent. So how long is the opposite? X over the adjacent, which is 3. Now from here it's just algebra, and the little rule that we ended up coming up with is whenever the x was on top, we just multiplied. So I'm going to do 3 times the tan of 54. Okay, so we have 3 times the tan of 54. Okay, so type that in your calculator real quick. Remember, when you do this, you need to make sure that you're in degree mode. Push doc 7.2. Make sure that second line says degree, not radian. So I'm going to go 3 times, and if you remember on these calculators, you push the trig button right here, and that brings up this trig menu, and we're going to choose tangent, 54, and so we get 4.13, which is going to be my x. Right. So trig menu up there. Alrighty. So that equals 4.13. And that's this right here. Okay. So now I have the apophyme. So now I can find the area of this base. Because we do apophyme times perimeter divided by 2. So the apophyme is 4.13. So 4.13 times what's the perimeter of the base? 30 divided by 2. So 4.13 times 30 divided by 2. 61.95. Okay. What's the height of this prism? 18 is the distance between the bases. So now for lateral surface area, we just do P times H. What does that give you? Okay, 540 square inches. Then for total, P times H plus 2 times B. What does that give you? 663.9 square inches. Okay, last one here. What's the perimeter of the base on this one? It's 24. Okay, now we got to find the area of the base. So we need apophyme times perimeter divided by 2. So I've got to find the apophyme. So again, that's why I have this here. Now this one's going to be a little bit different, but it's going to be the exact same process. And the reason it's different is because it's a different shape. The other one was a pentagon. This one's a hexagon. All right, so on this one, I'm gonna go do it the same way. So we're gonna do n minus 2 times 180. What's the n for this shape? How many sides does this shape have? 6. So 6 minus 2 times 180, what does that give you? Okay, 720. But that's the total. I want to know how big one of these angles is. Divide that by 6, what does that give you? 120. So this angle right here is 120 degrees, the whole thing. So if the whole thing is 120, how big is this angle right here? It's 60. Now from here, you could use special right triangles, but I'm going to go ahead and just use trig here. So I'm looking for this side over here. This side right down here is going to be how long? It's 2, because this whole thing is 4, so that's 2. So we have HAO. I don't need this one. So tangent, again. So we're going to have tangent of 60 degrees equals the opposite x over the adjacent 2. So we're going to multiply 2 times the tan of 60. And 2 times the tan of 60 is what? 3.46. Okay, so that's what this is. That is actually the apophyme. So now I can find the area of the base. Apophyme times perimeter divided by 2. What does that give you? 41.52. Okay, what's the height of this prism? 16 meters. So for lateral surface area, we do P times H. Which is what? 384 square meters. And then for total, it's P times H plus 2 times B. And what does that give you? Okay, quick, turn over to the back side of the page. All right, so on this first one right here, it took me a little bit to figure out what they were asking here, but anyway, so it says the Z company what specializes in caring for zebras. They make a three-dimensional Z. Whatever the Z is 15 inches thick, which is talking about this from here to here. And it says that the perimeter of the base is 390 inches. Okay, so what they mean by this, and this seems really weird, but when they're talking about the base, they're talking about the Z. So they mean that this right here is the base, which that doesn't make sense really to me because I don't know why they would make that the base. But anyways, that's what they mean when they're talking about the base. They're talking about the actual Z shape is the base, which makes this really a pretty easy problem, really. Okay? All right, just wanted to let you know that. All right, you can get grouped up. Go for it.